This is Epicenter, episode 323 with guests Silvio Micali and Steve Kokinos. Hi, welcome to Epicenter. My name is Sébastien Couture. Today our guests are Silvio Micali and Steve Kokinos. Respectively, they are the founder and CEO of Algorand. Of course, we had Silvio on the podcast before. It was almost 3 years ago in February of 2017. And back then, Algorand was just a white paper. You'll remember that Silvio was a professor at MIT and he'd written this paper which described this revolutionary new blockchain consensus mechanism. And I think a lot of people, including myself, were excited to see this seasoned academic and renowned cryptographer entering the space. I think to many people, it signified a certain level of maturity of the technology and of the ecosystem. After we ended the interview, as we often do, Mayor and I had a debrief, and I remember thinking, this is fascinating, but it doesn't seem like he's going to build this. I actually went back and listened to that conversation from 3 years ago, and he didn't leave many doors open to the possibility that he would actually work towards building Algorand. Well, sometime after that, Silvio was approached by some colleagues, and they began working with him to transform this idea into a company. Since then, he's left MIT, and Algren has grown into a company with dozens of employees. They've raised over $100 million, and they've launched the mainnet network. One of the things which fascinates me about this story is Silvio's seamless transition into entrepreneurship. I mean, Micali is in his 60s. He spent his entire career in academia. Of course, he and Shafi Goldwasser won the Turing Award in 2012 for co-inventing ZKPs. And just like that, he left academia and he took the leap into the blockchain startup world. And he talks about it with such ease and enthusiasm. And I think this is one of his many qualities. And I think probably most people wouldn't be able to do this at this stage in their career. So, hats off to him for doing that. So in this conversation, we revisited how Algorand works. We talked about the scalability aspects and how Algorand claims to solve the blockchain trilemma. We talked about VRFs and their role in the protocol, and also the roles of the different participants in consensus. And Steve Kokinos, the company's CEO, helped us understand their philosophy when it comes to building the product. Their approach to developer experience is somewhat unique, I think, if you compare it to other Layer 1 protocols. The smart contract language, Teal, is a set of about 30 instructions rather than full Turing-complete programming language. And they've chosen to build some DeFi components right into the protocol. So things like asset issuance and atomic swaps are built right in, as opposed to leaving that open for the community to build as layers on top. So I think if you compare Algorand to things like Ethereum, Cosmos, and Polkadot, there are some important distinctions in terms of product philosophy. Before we go to the interview, I'd like to tell you about our wonderful sponsors for today's episode. Societies across the globe need technology that gives them monetary independence, voice, and sovereignty. And this is the mission of the Status Network. It's an organization building tools and blockchain infrastructure at every layer of the tech stack. Status combines a decentralized messenger, wallet, and dApp browser into a powerful, private, secure communication tool. It uses a peer-to-peer protocol and end-to-end encryption to protect your communications from third-party interference. There is no email and no phone number required to set it up, which is one of the things I love about Status. And the peer-to-peer messaging means that your messages are never sitting on a server anywhere. When you send someone a message, it goes from your phone to their phone. The crypto wallet allows you to safely send, receive, and store crypto assets. Only you hold the keys. This is a serverless wallet. And the built-in Web3 browser allows you to navigate the growing ecosystem of decentralized applications right from your phone without being tracked. To learn more about the Status Network and all of the components which make up this ecosystem, go to statusnetwork.com and go to status.im to find the beta for iOS and Android. And please join the public channel. It's #Epicenter. And if you message me there, we'll send you some free SNT tokens so that you can create your own ENS domain name in Status. We'd like to thank Status for their support of Epicenter. We are also brought to you by Cosmos, the Internet of Blockchains. The Internet Blockchain Communications Protocol, IBC, enables a massive variety of networks to coexist, each with their own features and purpose, communicating with a trustless protocol. Now, Ethereum is obviously a massive part of this interchain, and aspects of its infrastructure will show up in many different places. One of the ways Ethereum shows up in the interchain is with the Ethereum virtual machine. It's a time-tested, secure execution environment that provides properties that make it ideal for smart contracts. So if you're building a network outside of Ethereum and you want to utilize the EVM, one of the ways you can do this is with the Cosmos SDK and the included Ethermint module. Algorand recently decided to run their own network that utilizes this infrastructure in order to make protocol-level decisions for their users. This enables them to modify things like gas cost, increase throughput, and design their own token economics from the ground up. So if you're interested in learning about building application-specific and interconnected blockchains, and if you're going to East Denver, you should join their workshop. It's on Wednesday, February 12th during Biddle Week. This session will be a hands-on instructional course that uses the Cosmos SDK to build an NFT blockchain. They'll go over the process of deploying your own EVM blockchain that you can interact with via MetaMask and utilizing all of your favorite Ethereum developer tools. To connect with the Cosmos team and to learn more about how you can join this workshop, go to the Cosmos forum. That's at forum.cosmos.network, and you can talk to somebody there who can tell you more about the workshop. We'd like to thank Cosmos for their support of Epicenter. We're also brought to you by Peppo, where the crypto community comes together with short video updates and tokens of appreciation. So whether you're a crypto developer, a podcaster, an analyst, a blogger, or an enthusiast who's just interested in the space, there's never been an easier way to showcase your work, earn appreciation, and connect with the community. So Charlie Shrem is on Peppo, Alex Van de Sande of the Ethereum Foundation is on Peppo, Anna George of Gnosis is on Peppo, and Evan Van Ness of This Week in Ethereum is also on Peppo. So you can talk to these people directly and all of the other great content creators that are exclusively creating content on Peppo. What I love about Peppo is that you collect more than just likes. When you like something, when you want to show your appreciation for content, you tip people with Peppo coins. And unlike Twitter, much of the spam is eliminated because you actually have to put up Peppo coins and able to respond to videos. Peppo is fast, it's easy to use, and you'll reimagine what's possible with crypto. I love that with Peppo, you get to see how crypto is applied to a social network that anybody can use. So to download Peppo for iOS or Android, go to peppo.com/epicenter. That lets them know we sent you, and you can find me there. My username is @seb2.0. That's @SEB2POINT0. We'd like to thank Peppo for their support of Epicenter. And with that, here's our interview with Silvio Micali and Steve Kokinos. I'm here with Steve Kokinos, who is the CEO of Algorand, and Professor Silvio Micali, who invented Algorand and is leading research at the Algren company. Hi, guys. Thanks for joining me today.
Hey, thanks for having us, Sebastian.
Silvio, we had you on the podcast about 3 years ago, and back then, Algorand was just a white paper and an idea. And I remember after the podcast thinking, I wonder if anything's going to come of this. Like, I wonder if someone will pick up the idea and go out and build it, because at the time you didn't really seem to have any ambition to do anything with this, except just that it was like an interesting research exercise for you. At least that was my impression. Tell us, what's that journey been like? Like, what happened from then, which has got you to where you are now, now with the company and tens of people working for you and having raised funds and everything?
Somehow, my research interests have always been historical in cryptography and Byzantine Agreement, and more recently, mechanism design, economic mechanisms. So somehow, finally, I learned about Bitcoin, and I felt it was a fantastic problem, but an inelegant solution. Great idea, first idea, but I thought it could do better. And by the time in which, we first spoke, Sebastian, I felt, I just wrote of a white paper. Usually my style is to publish in reviewed conferences, journals, and things like that. But this time, and I really felt, I wanted to put it out there a bit more in the style of the community as on electronic archive and see what feedback I got. But the feedback I got was not electronic. Somebody knocked at the door of my office, and it was my good colleagues in systems, Nikolai Zeldovich, which is a few floors up in our building. And he says, Silvio, this stuff is too good to be true. Okay, do you mind if we test it? And of course, I said, listen, do I mind? Why should I mind? So we prepared a very rigorous test with involving actually a few other people who became now the core of the Algorand team, on the engineering team. And we rented some, I think about 1,000 big servers for Amazon and tried to simulate the protocol with 5,000 users at first, 10,000, 50,000, 100,000, up to 500,000. We wanted to simulate it up to 1 million, but we needed to find 2,000 servers, and we couldn't find any day in which 2,000 servers were available. But in any case, it was irrelevant at that point because we wanted to test the scalability of the system. And we saw that after 75,000 users, there was no added delay. So the system, surprise, scaled as the mathematical analysis suggested. So we thought that we publish the paper with Nikolai and Yossi and Derek and Yorgos, and it was a very proud. It was my first system paper. And at that point, first there was an idea, then there was actually an experiment, and all of a sudden I said, gee, maybe the stuff works. Maybe we should form a company and develop it. Also, because I must say, in the past I saw that it was really a long time in which the basic ideas that I was developing, starting in the 1980 on public key cryptography, it took a long time to get into society. And I decided we had to accelerate this. And so forming a company was really the right thing. I happened to share an elevator ride with Jamie of Pillar, who would end up being one of our investors in Series A. And the other one was Albert from Union Square Ventures from New York. And so, we had the classical elevator pitch. Says, what are you doing? So let me tell you what you're doing. He says, oh, yeah, it sounds interesting. So we started talking a bit more, and later we decided to start this company. And initially were 11 people, 8 of which are from MIT. And one of the first good things that Jamie did is to introduce me to Steven, and the rest is history.
That's a hell of a journey. And so this is your first entrepreneurial experience outside of academia, I believe, right?
Yes, I have some of my technology has been used by other companies, but I never left MIT to give a hand to this company. I just licensed the technology or assigned patents. And this is instead, it was so much fun that I really actually took first a sabbatical and then a leave of absence from MIT to be part of a company. It has been a great ride even ever since. And we launched in the blockchain in June, and last November we added another major injection of technology by doing at layer 1 all kinds of cool stuff, atomic swaps, smart contracts, issuance of your own assets, and which usually traditionally are done by smart contracts, and so therefore they are very fragile. And now we did it very direct, very secure, and very fast.
Cool. And Steve, how did you come to meet Silvio? And tell us a bit about your background as well.
Yeah, well, I'm a serial entrepreneur. So I got my start in the early days of the internet, in the mid-90s, when I was a young guy. I actually started my first company when I was still in college and sort of built that up, sold it in 2000. But, we were one of the first handful of infrastructure providers back then, ended up building 10 data centers around the world and servicing some, really interesting projects. From there, I was a co-founder of a company called Blade Logic, which was early data center automation software. And I'd say it was sort of like a precursor to a lot of the cloud utilities that people use today. Helped grow that business. Blade Logic went public and then was acquired by BMC Software after. And then for the decade or so prior to Algorand, I was founder and CEO at Fuse, which is a cloud collaboration platform focused on enterprises. And I guess a couple of years ago, I decided that new challenge might be fun, and decided to stop running Fuse day to day and had also been fortunate to be involved with Pillar. I was one of the early investors there, which was founded, as Silvio said, by Jamie Goldstein. The thing that really struck me was that crypto and blockchain tech were sort of the first things I had seen in the intervening 20 years that had, a lot of the dynamism and, also kind of philosophical underpinnings that we saw in the early days of the internet, which I know it's sort of hard to believe now, but, the early days of the internet were very much about self-publishing, giving people a voice out in the market. It was very anti-commercial and had a lot of libertarian underpinnings as well. So I thought it was fascinating that the crypto had, what felt to me like a lot of similar ingredients. If you take a step back, one of the things that I sort of observed was that the financial world and sort of the way people transact hasn't really changed that much in 20 years, whereas, the ways we do a lot of other things has changed a lot. And so in any event, I had been sort of exploring different things. I was doing some mining with my kids, like as a hobby in the basement of my house. And Jamie suggested one day, he happened to be by my office, that I walk over and have a chat with Silvio. And to be honest, I didn't really know what I was getting into, but I had a fascinating discussion with Silvio and, ended up getting involved. And it's been a real adventure, but it's I think both the tech and kind of the business and, even broader sort of social possibilities are awesome here.
What was it about Algorand that really caused you to flip the switch and, make a full swing into the crypto space?
Well, I think that, kind of the color that I just shared was part of it. But I think what really struck me is, when I was a young guy, there was like lots of people who started internet companies and did pretty well, sold their businesses. But what I observed sort of back then was that it wasn't really the first movers, the people who were in super early, that built generationally meaningful businesses. It was, the folks like Google and others where they got to see what mistakes were made in the first wave, really rethink the tech from the ground up, and also partner with business people that had experience scaling organizations. And to me, it felt like Algorand could possibly be one of the winners in the space. Certainly, Silvio is a brilliant problem solver and has created amazing tech. Ultimately, that's what really got me excited about the project, is that it felt like there was a lot of early enthusiasm, but really there was going to be a next wave where bigger things were built.
Yeah, that's an interesting way to look at it. It's not necessarily the first movers that are successful. Do you think that this idea applies also to blockchain, where there's massive network effects and massive economies that are built around things like Bitcoin and Ethereum and like the first blockchains to hit the market?
Well, I think for sure there's network effects and there's first mover advantage. I would say that, often in these sort of nascent markets, they take a little longer to develop than people think. And I'd say there's often sort of pre-first movers, where it's really just like the first people who got into the space. They often benefit sort of greatly from that, but aren't necessarily the sort of companies that end up winning out. If you look at where we are today, I think our belief is that we're at the start line of a 20 to 30 year reformulation of how the world's financial systems work. That's probably not that dissimilar in terms of scope to what's happened over the past 20 years. I mean, I think using a dial-up modem like in 1996,
which I was,
and trying to use like a crappy browser and waiting 5 minutes for a banner ad to load, it was a little difficult to like imagine your kids watching Netflix in the back of their car on their iPhone. There's sort of a similar progression that has to happen there. I also think, though, that network effects are very important. One of the things that Silvio can elaborate on this better than I can is in the space, the products or sort of the technologies that are out there, the first generation technology simply can't scale to handle the throughput of the entire world. And again, you just need the underlying bandwidth, which is why we believe so strongly in solving these fundamental layer one problems, because we think that, one, putting the right tech out there is important. I think separately, we aren't believers that it's a single chain kind of, all or nothing is going to rule the day. We think that Bitcoin is for sure established itself as the reserve currency of the crypto world and will continue to thrive. We also think there'll be other chains that focus on, different elements of what becomes a technology stack that are needed. But we think Algren can be one of the sort of handful of of key platforms that succeeds out there. But yeah, I think you need to generate network effects. You need to kind of also make it really simple for developers and for people to build on top of the technologies. And, today the user experiences are terrible. Both end user and developer experiences, I'd say, kind of across the space. So that's something we're really passionate about, is starting to be one of the players that thinks about that and fixes some of those problems.
With your previous experience in like cloud-based communications platform, when you came into space and started working with Silvio, did you see anything that blockchain was able to solve? Like, did you see any problems in your previous experience where you thought, blockchains can solve this, or like blockchains can provide a solution for like this problem that I've encountered previously?
They're very different very different problem surface areas. I think between, say, communications and blockchain, at least from a tech perspective. But I think there's some simple things in the world where, blockchain is ultimately about helping create trust between people that have no way of transacting. And I think if you, think about simple cases where I may want to order something from, a product to be created. Maybe I want to use a Chinese supplier. They want me to send the money before they ship me the goods. I'd rather they ship me the goods before I send them the money. And if one party doesn't hold up their end of the bargain, the legal system isn't really going to provide a great remedy for that, because it's not like people are going to fly and try and use the legal systems in places where they aren't. I think that there's a certain type of business and type of exchange that lends itself naturally toward decentralized systems where sort of both parties can trust in the algorithmic nature of the system versus, kind of a paper legal system. And so I think, to me, that was something that I thought was very interesting. And what we really feel is that, the decentralized world really represents a new form of economy. And there's certain businesses that by nature will, have desire to transact there and will solve really meaningful problems for them. There's other businesses that aren't going to be decentralized. In the early days of the internet, my dry cleaners didn't need a website. They don't need one now. They don't have one. They probably had one somewhere in the middle there, but it was nonsense. And so I think that they don't need to be decentralized either, but I think there are a lot of problems that can be solved there. And so if you look at some of the features that we've introduced recently, like atomic transfers, the ability for people to exchange in, kind of one step, being able to, create conditional smart contracts and, issue new types of assets, all those things are designed with, kind of the kinds of problems in mind that are real business needs that exist out there versus just sort of putting stuff out and seeing what sticks.
Sebastian, I totally concur with Stephen. So you must know that this the problem of a fair exchange. For instance, you have an asset that I want, and I have an asset that you want. Who gives the asset first to the other one? Or even if it's not an asset, I want your digital signature on a contract, and you want my digital signature on a contract. Who signs first? By the way, in the 80s, that's one of the problems which I tie myself in knots in order to try to solve without a blockchain. Once I saw a blockchain, it says, hey, that is now all these things have a much easier solution. Why is the solution much easier? Because it is buried under this extraordinary tool, which is the public permissionless blockchain. And so you get all the technology over there. You get for free a lot, or almost for free, all kinds of very sophisticated architecture. And that is what is the beauty of it, that you have now a platform, if you engineer it correctly, which allows you to do very elementary and very simply all kinds of things that used to be extremely complicated, even with public key cryptography, zero knowledge, and all kinds of other complications.
What problem does Algorand address that other blockchains have not been able to address so far? What does it bring to the table?
First of all, when you talk about Algorand, I really want to explain to everybody who's listening your podcast that Algorand is emotion. So different from other blockchain in which what you start is what you get. We continue to innovate another platform, and we have a very deep roadmap which is going to keep us busy for a few years. So let me tell you that the first problem that we actually solved was the famous blockchain Trilemma. Right? So that was enunciated a few years back by Buterin, the co-founder of Ethereum. So what does the trilemma say? The trilemma says that it is impossible for a blockchain to enjoy simultaneously all the following three properties: security, decentralization, and scalability. So just imagine if this were true. I'm now a company, blockchain by design. I'm a consultant. You come in my store and I give you a blockchain that is right for you. Okay. Oh, welcome, Sebastian. So I have really a blockchain that is really perfect for you. Do you want this blockchain that is insecure? You say, well, not really. So, okay, you care about security. Good. So how about we give you this blockchain, which is pretty much centralized, but otherwise has all the other property? Well, if you're interested in a blockchain, why do you want to have one which is centralized? It is totally nonsensical. And similarly, perhaps you don't care about scalability. No, I do care about scalability because otherwise, what I'm going to use the blockchain for? To interact with friends and family. It is incredible that for a long time, no blockchain could satisfy these three properties. And I think that the first thing that Algorand did is to somehow prove that Trilemma false. Yes, it was backed by a lot of empirical evidence, but there was another way to skin the cat, another way to organize a blockchain that allows to enjoy all these three properties at once. And that's what Algorand was initially. Then, moving forward, as Stephen mentioned before, the ability to have a layer one in a very direct and secure manner, as if there were ordinary payments to handle the issuance of assets, to having atomic transactions, and a layer one smart contract is equally important. Just imagine if you are a typical application of a blockchain. Think about supply chain, right? So people can put on the blockchain all kinds of things, as let's say is coffee, okay? Somebody in the mountains grew the coffee. Okay, so he has to be paid. Somebody has to bring the coffee from the mountain to the plane. He or she has to be paid too. Somebody puts them on a truck and transports to a harbor. That wants to be paid. The ship wants to be paid, and so on and so forth, right? So who goes to pay first? You have to do all these 12, say, payments. I think I mentioned easily if you match on another 6 payments on the other side once you want to deliver the beans to be roasted. You have a tremendous amount of payments, and you have to update all these 12 ledgers in different currencies all at once. And it takes, with today's technology, 3 months. So to be able to do it in less than 5 seconds, treating them all these 12 separate transactions as a single transaction, the fact that you can somehow authorize your own piece of this transaction, knowing that it's not going to be executed at all, but it's going to be executed in a few seconds anyway, and only when all the other transaction is also executed simultaneously with yours, is a great benefit. And so next step for us is going to be having a general purpose smart contract that is going to be as innovative as we have been in our consensus protocol. Next is going to come with, we find the right balance, we believe, between permission and permissionless blockchains, which I believe is going to be a synergy between the two rather than either one or either or. We are going to leave our mark in this history of the blockchain, but the first one was the solution of a trilemma.
Talk about how Algren solves this trilemma. This trilemma of you can only have 2 of 3: security, scalability, and decentralization. How do you solve this?
I want to, first of all, to make sure that your listeners understand the first thing. What is really hard in a blockchain, what is it? Is a database organized in blocks, block 1, block 2, block 3, such that everybody can read all of the blocks, everybody can write an entry in one of these blocks, and nobody can alter neither the content of a block or the order of any block. All this inalterable database, it's actually trivial from a cryptographic point of view. If you're a cryptographer, it's trivial. You take the previous block, you hash the hash of the previous block, you include it in the next block, and that prevents anybody from altering the content of a block or the order of a block. All 2000 and change blockchains right now, they use the same technology for achieving this inalterability. So what is the challenge? The challenge is choosing the next block. Because what is the next block is going to contain? All the valid transaction that if you've seen propagated in the network. I want to make a payment to you, I digitally sign it and propagate it in the network. Eventually, every node will get it. But they get it at different point in time. In your opinion, the next block is a bunch of sticking to payments right now of, say, 1,000 payments. I may see 990 payments instead, and I'm going to have perhaps seen 100 payments you didn't see, and I missed some 80 payments that you saw instead before me. In my mind, the next block is slightly different than yours, and the one of Steven is slightly different from the two of us, and so on and so forth. And of course, even a minute difference or a small percentage difference accumulated block by block create a tremendous confusion about what the ledger ought to be, what the history of all these transactions is going to be. So who chooses the next block? That's the whole difficult problem. And Nakamoto, Mr. or Mrs. Nakamoto solution was actually brilliant. Was the first idea to say, hey, we are going to have a computational game. We are going to propose a very complex cryptographic riddle. The first one to solve it has the right, if he presents the solution to the riddle, to append the next block to the chain. And this riddle is going to be so hard that no matter how many people on Earth try to solve it, only one solution every 10 minutes will be found. And that is actually is important, this slowness, this one solution every 10 minutes. Why? Because say two people, say you in Paris and another lady in Thailand, found a solution a few seconds of each other, then you actually have a fork in the chain because you don't know if the next block is yours or hers to a viewer, right? So what you want to do is to minimize the number of forks, because when there is an occasional forks, we can resolve it and go back to a unique single chain. But if forks are too frequent, then this resolution is going to be essentially impossible. If you look at this, it's a brilliant idea, but is a slow, obliges the blockchain to grow very slowly, and is a very expensive. Why? Because more people want to participate to the generation of a new block, and therefore, the more people participate, the faster solutions are found. And so therefore, the riddle has to become more and more difficult, to the point in which you have to consume an insane amount of electricity that powers the computers, the only purpose of which is to solve this riddle. And in fact, it's so expensive that fewer and fewer players can actually play this game, because you don't have to have only one computer, but and not only a specialized computer, but racks and racks and racks of thousands and thousands of computers. So pretty much this becomes a fewer and fewer people's game. And right now, the blockchain of Bitcoin somehow could be controlled by free mining pools. And if you look at this, is free mining pools decentralized? No. The world needed an alternate solution, and alternate solutions were found. The first one was proof of stake. But it's important to understand that proof of stake is not one technology, it's a portfolio technology. Typical proof of stake is called the delegated proof of stake, which for all intents and purposes can be summarized as follows. You see these 21 people? Don't they look honest? Well, if they look honest, I believe they are honest. I further believe they will continue to be honest in the future. So why don't we delegate all of us to just them the problem of generating the next block? So if you have a delegated proof of stake, if you ask me, is centralized from the get-go. At least in Bitcoin, right? Everybody could, in principle, participate by solving the riddle to the generation of the next block. Here, we are actually concentrating it into the hands of 21 people. And then the debate is 21 is not enough, 50 is the right number. Libra says, no, it's 100 the right number. Well, 21, 50, 100 is all centralized, right? And the next thing is a bonded proof of stake. Bonded proof of stake is another simple idea, which can be summarized as follows. In bonded proof of stake is not 21 people or 200 people. Is as many people are willing to put money in the middle of the table, where they cannot touch it, are the ones in charge of generating the next block. And their influence in generating the next block is proportional to the money that they put at stake, bonded, in the middle of the table. What's the problem with that? The problem with that is that I'd like to ask your listeners, say, hey, how much of your disposable income can you put in the middle of the table where is hostage, right? Not invested, not ready to be spent, just a hostage. The answer is going to be, for most of us, a very small fraction. So in a system like this, not only you make it possible, but you make it easy. In fact, you actually roll out a big red carpet for big thieves with deep pocket to put a disproportionate amount of money in the middle of the table for the sole purposes of controlling the chain.
What you just described, there's two issues that are somewhat compounding. So the first issue is that one of the problems that blockchains has, and I would say is probably the base layer problem with all blockchains, is a networking problem. It's getting blocks to people fast enough so that everybody can agree this is the next block. I believe it was Uri Klarman of Blocksprout who came on the podcast a little while back, and this is how he describes it, is the fundamental problem with layer one is a networking problem. The issue that you have when you can't get over this networking problem is the issue of centralization of power. And so with Bitcoin or with proof of stake or delegated proof of stake or bonded proof of stake, rather, there's this issue where at some point specialization makes it so that you have centralization of validating power. And that's just due to the nature that validating a blockchain is complicated. And we're going to need specialized actors to do this sort of thing.
Essentially correct, but I beg to differ a little bit. So this network, without much very sophisticated routers, one block can actually be can cover an entire planet in a second. That's not the problem in itself. The problem is actually choosing the next block. Once it's chosen, you can propagate it very quickly. But choosing the block is what slows down a lot of things. And that's why you needed to have the computational game that slow down Bitcoin. And that's you have the concentration of power. Let the 21 people, you narrow the number of people who can choose the block. You can choose the next block more quickly. So in Algorand, essentially, we solve a problem in a very counterintuitive way to enable anyone who has a token of Algorand. Any token has the same ability to participate to block generation. Essentially, here is as it works at a high level, right? Every token, once you see block 100, the question is, what is block 101, right? So what happens is that in Algorand, you have, think of it like two magic phases. The magic is actually replaced by mathematics, but never mind, over the radio is easier to talk about magic. Magic phase one consists of the following. Every token is going to ask, am I perhaps the one who are going to choose the block? To solve this problem, you actually do a lottery, a cryptographically fair lottery that decides if you are going to propose a block. The lottery is organized so that, simplifying things, there is only one winner. And the winner, if you win the lottery is cryptographic, means two things. A, I cannot, even if I have enormous computational resources, to increase my chance of winning. But if I win, I have a proof that I won the lottery, and I can somehow disseminate to the network my proof that I won the lottery, and therefore that's the block that I propagated. And I propagated my chosen block. I prove this proof and the block I propagated at the same time. End of phase one. Phase two, somehow everybody again tries to run a different lottery. This time the lottery selects at random 1,000 tokens. And the owner of these 1,000 tokens are part of a committee who agrees on the block proposed by the first person. And why do you want to agree? Because any society has a percentage of bad actors, maybe 1%, 2%, maybe 10% if you live in a very dangerous society. And so when this happens, if a bad actor has won the first lottery and propagates a block, nobody's guaranteed that he or she cannot tell you one block and me a different block and Stephen yet another block and your listener all kinds of different blocks, thereby generating confusion. There is not a chain anymore. There is a mess. But when you have actually 1,000 tokens, essentially selected at random, and if most of the tokens are in honest hands, which I believe is a safe assumption, then the majority of these tokens are going to be belonging to honest people, and therefore the committee has an honest majority, and such a committee agrees on only one block and not two. And therefore, that essentially is how you guarantee that there is one block and this block has been agreed by things. So the real question is, how do I guarantee that I'm part of this committee? Because, again, it's a cryptographically fair lottery. If I win, I get a proof. I cannot cheat the lottery to improve the chances of winning. So if I'm a part of the committee, I give you a proof that I'm part of the committee, that I won the lottery, and I give you my opinion up or down about the validity of the block. And this pair of proof and opinion is disseminated over the network. So why is this scalable? Because how long does it take to run this cryptographic lottery? 1 microsecond. That's very fast. Okay, so that is scalable, Is it this distributed? Well, absolutely is distributed, because we are not concentrating the power in one person, 21, 50, or 100. Every token, and in Algorand there are 10 billion tokens, has the same probability of every other token of winning the lottery and be part of this committee. So that is very distributed. And by the way, if you win the lottery, what you have to do? You have to propagate your winning ticket, your proof that you won the lottery, and your opinion about the block. 1,000 people tops can win this lottery. Can the network absorb the dissemination of 1,000 small messages? Absolutely. That's why it's scalable and distributed.
I just want to stay on the lottery for 1 second. So when you say 1,000 people can win the lottery at any time, of those 1,000 people, there's one participant that ends up creating the next block and propagating that block to the rest of the network, correct?
Yeah, that happens in the first phase. In the second phase is essentially an agreement phase, in which you say, okay, we heard something about, we reach a Byzantine Agreement, and Byzantine Agreement is a process by which, say, 1,000 people or a group of people, the majority of which are honest, they try to establish a common output, so a common block. And the block is that if we are going to have this process, Byzantine process, at the end of which I output one block, and I know that if I'm honest, then every other honest person, the same vote of the block that I'm propagating. Therefore, if you see a block that, say, has 700 votes of this committee, you know belongs to the committee because you have seen the winning tickets. And if you see 700 winning tickets voting for the same block, you say, oh, gee, that has to be the block that is the next block in the chain. And end of story. You don't have to wait that there are possible forks. You don't have to wait that new blocks are actually added to my block and over again, so that the block becomes deep enough in the chain. As soon as you see a block backed by the majority of the committee member, bingo, that's the next block. Our next step, we agree on the next block, and so on and so forth.
So I'd like to ask you about how this information is propagated. And specifically, my question here is, how do you get over network propagation issues that can arise, right? Because if the assumption here is that anybody can be a validator and there are no specialized miners, then someone can be validating on a mobile phone, presumably, or maybe on like a remote, like on a desktop in a remote location. And the quality of each's internet connection can vary widely. And if one has to propagate a block, let's say we now assume that blocks, if we're scaling, that blocks can get, at several megabytes, for instance. How do you solve that propagation issue where you don't have specialization of validators that have very high-end internet connections and that can propagate these messages and the blocks at high speeds?
First of all, even with modest 20 megabit connections, you can do it quite well, and they are heard by everybody. But remember that we produce a block in 5 seconds just because we want to make sure that this block is actually seen across the network. But it doesn't need to be seen by everybody. What we need is to make sure that one block is seen by at least not by everybody, because you're never sure. Somebody is at the edge of a network, maybe 90% of the participants. And that is the idea. There is actually a further idea that Algorand has, a property that we have not discussed yet, that guarantees actually that the protocol security does not depend on the security of the underlying communication network. So in other words, if somebody, an adversary, tampers with a network, communication network, with the wires, with the routers, it can destroy somehow proof of work approaches, but it cannot destroy the Algorand approach. Of course, if an adversary prevents all of us from sending messages, well, nobody can produce a block, not in Algorand, not in Bitcoin, not in Ethereum, not in anything, right? Because if we are isolated in Faraday cages, nobody talks. But if you can somehow partition the network, even by cutting wires or by reprogramming for an hour the relevant routers, and you say isolated, think of it a continent, say South America, for an hour, then suddenly, by the time in which you realize something wrong happens and you patch together the communication network properly, you restart the routers, you reconnect the wires, whatever you have to do, unfortunately, in classical protocols, a lot of people can lose a lot of money because you can actually have double spending after such an attack. So people usually worry about attacks on the protocol, but the protocol is a communication protocol and is only as good as the network on which it runs. And somehow it could actually be cheaper or more possible for an adversary to attack the network rather than the protocol. And in Algorand, you are secure against the protocol attacks and network attacks. First of all, so if I may spend, I don't know, some time to say, why is Algorand secure about the protocol attack first? So before I was saying that, remember, I have a winning ticket if I'm part of a committee to approve a block, and I propagate my winning ticket and my opinion about the block. Now, let's assume that I am a bad guy, which is extremely powerful. I'm so powerful that I can corrupt any 1,000 people on earth that I want simultaneously, okay? At the snapping of my fingers, okay? Very easy for me to do so. Whom I want to corrupt? Well, I want to corrupt the committee of 1,000 people almost that is going to approve the next block. That's where the security of Algorand comes from. But I have a problem. I do not know whom I should corrupt because the committee is selected by a cryptographic lottery, so I do not know which people on earth are going to win this lottery. If you in Paris, this lady in Shanghai, and so on and so forth. But as soon as the people spontaneously come forward by announcing, here is my winning ticket, I'm part of the committee, and here is my opinion about the block, pay attention to it, now I know whom I should target, and I can corrupt them immediately. But guess what? At that point, the message of the committee members are virally spreading across the network, and I cannot put them back in the bottle no more than the US government or any other government can put back in the bottle a message virally propagated by WikiLeaks. So in some sense, Algorand is secure because beforehand, an adversary does not know whom he should corrupt, and ex post is a bit too late to corrupt them.
Because of the randomness in the lottery. And then how does Algorand protect against the network component?
Okay, first of all, it's easier to let me first understand, why, say, Bitcoin is vulnerable to network attack, in particular to partition attack. Okay, so it's a bit easier to see the problem we're trying to solve first. So, okay, let's assume that all miners in the world are all honest. Okay, very good. Good news. And miners are geographically dispersed, right? And there are in North America, South America, Africa, Asia, Europe, all over the place. Okay, 5 populated continents. Antarctica is still not very populated. Right? So imagine that an adversary cuts the cables going to South America. So South America is isolated from the other continents. There are 5 continents. South America is isolated for an hour. I mean, a smart adversary allows happy birthday messages to go across, but Bitcoin control messages are not let in or out of South America. So what happens? The South American can extend the chain among themselves, with every time that one of them solves a riddle, attaches a block. So you start producing blocks, but at a much slower pace. Why a slower pace? Because 1/5 of the miners in South America, so we say with speed 20, you attach a block. Meanwhile, the other 4 continents, also solve the riddles, but they solve it at a much faster speed than South America, because there are 4 times the miners in the rest of the world than in South America. So they proceed at a speed of 80 miles an hour. Think about 2 cars. One goes 80 miles an hour, one goes 20 miles an hour. Even if the car who goes 80 miles an hour starts later, eventually will surpass the other one and will form the longer chain. So if I'm a bad guy, what I'm going to do? I'm going to spend $1 billion in South America, get an asset, say a super duper transatlantic ocean liner, whatever I can buy with $1 billion. And once I have it, I can even reconnect the cables, because at that point, my debt will be erased. Why? Because after I put together the wires, even all miners, including the South American miners, will say, gee, what we were doing? We were elongating the shorter chain. The longer chain is this other one. Let's work on the longer chain instead. And my debt, my $1 billion expense is erased. And essentially, that's how partitioning the network, even if all miners come from the first to the last one, are totally honest, that's a problem. Instead, if you think about Algorand, now we said, we have a committee of 1,000 people, and somebody partitioned the network in the 2 chunks or 3 chunks or 4 chunks. What can happen? First of all, it could happen that the network production of blocks stalls, but the same could happen with anybody else, because in no connected part of the world you find enough votes to mint a new block. It's okay. Suspension is not a problem, because after connectivity is restored, you'll continue where you left it with nobody losing any money. But the other thing can happen is that, well, one part of the world gets maybe 100 members of the committee, but the other 900 are connected enough, and they see that a new block they are capable of producing a new block. That's okay. So a new block is added to the chain, which is seen, say, by 4/5 of the world, but not by another 1/5 of the world. That is not a problem, because once the connection is resumed, nobody has lost money, and everybody says, oh, gee, I didn't see a block for a while, but I see that when I was offline, so to speak, another 10 blocks have been added, or another 20 blocks have been added. That's the chain. Let me continue from there. So in other words, there is a very big difference. Anybody can, by tampering with the network, can oblige a blockchain to come to a stop, a temporary stop. Maybe yes, maybe not. But even if it comes to a stop, when you resume, nobody should lose any money. And that's what Algorand allows.
Okay. And so can you explain then this lottery, how it works and how it leverages verifiable random functions?
Well, verifiable random function is a way essentially to say, I'm going to associate to anything, but like a bunch of random bits, which are not under my control, but I can prove what bits I got, right? And so what I want to associate it is to say, is this public key of mine, or is this token of mine a member of this committee number n+1? To this event, a verifiable random function associated a string of, think of it like 300 random bits. These bits are not in my control, because they depend on the input, which is committee membership of block n+1. This sentence alone as for my public key. This gives immediately a bunch of random bits, which is not under control of my key or anybody. So, and from these bits, essentially, you can interpret like, a number between 0 and 1, you put a decimal point in front of it, and you have a binary expansion of a random number between 0 and 1, and you say, if this random number is less than a given threshold, my public key is part of the committee. If it's not part of the committee. And because it's provable, whenever I am below the threshold and I'm part of the committee, I prove to you my public key as associated with numbers for block n+1. Therefore, I'm part of this committee. Here is the proof of these bits. By seeing the proof, you know that the bits are random. By seeing the proof, you know that I could not have tampered with these bits in any shape or form, and therefore I'm part of this committee. The end. Roughly, that's how it works. So it's some randomness that you can prove, but you cannot choose your own random bits, like nobody should be doing. They are somehow automatically assigned to your public key.
Okay. I'm trying to wrap my head around the concept of the verified.
Let me give you
really
an alternative solution, which is a little bit more less mathematically sophisticated, but easier to understand. Okay. Remember, you have a signature, digital signature key, and you have a public key. Call it PK. Who knows the secret key associated to PK? Only you do, right? I cannot forge your signatures. So what happens is that when you want to associate a random number to your public key relative to an event X, what do? You digitally sign X. Only you can do the signature. I cannot predict what your signature is. Further, you hash your signature of X. Everybody can do once the signature has been produced. So the hash of your signature of X is essentially a random number. A verifiable random function can do better, but that's good enough, right? So, and that is your signature that you associated to your public key and event X. Now, I cannot dispute that this is your signature because anybody can verify whether the signature of X is correct or not relative to your public key. And having done this, everybody can hash the signature. And having done that, everybody computes a string of random bits associated or pseudo-random bits associated to your public key and X. And nobody can dispute it. Only you know which random bits are associated to public key and event X, because only you can digitally sign X. But if you can give me a digital signature of X, I can verify your signature. If the signature is correct, then I can hash it. And then I can check whether or not the bits that you claim to be the random bits associated to your public key and event X are right or not. Essentially, that is the way it works.
So in this particular proof of stake model that you have in Algorand, there's this randomness. The coins are chosen at random proportional to one's coin holdings, right? So that could be, I guess, sort of like their voting power. And so your probability of being chosen in this lottery is proportionally higher if you have many coins, right? Does it make a difference if one's coins are in a single account or in separate accounts? How does one stake, I guess, is the way to put it, their coins in this lottery?
Correct, because essentially this lottery is a token by token, right? So assume that in Algorand there are 10 billion tokens. If you have one token, you have 1 in 10 billion probability of being chosen, okay? If you have 2 tokens, you have a 2 in 10 billion probability of being chosen. If you have 100 tokens, you have 100 everything. And if you look at this, assume that you have 1,000 algos, 1,000 tokens. You say, gee, I want to maximize my probability of being chosen. Should I hold these 1,000 tokens in one public key, or should I split it in 2 public keys, or should I split 1,000 public key, each one with 1 token? Because your number of tokens does not change, and the probability of selecting is token by token, whether you hold all your token in a single key, or you distribute your 1,000 token across 1,000 keys, your probability of winning the lottery is absolutely the same. That is the good part. The only thing is that the way I describe it, token by token, you have to worry, say, gee, but now you have to do 1,000 digital signatures and 1,000 hash. So, and we have actually the technology to speed this up. So to make sure that in a single signature, you realize if you win or lose, whether or not you have 1 token or 1 billion token is the same easy. 1 signature is enough. You need a bit more mathematics to do that, but that's what we do.
Okay. Stephen, I'd like to turn it over to you a little bit and talk about some of the primitives that you've built into Algorand. So we were talking about this before the show, and so you've built in 3 components into the Algorand layer 1, atomic swaps, asset issuance, and a smart contract language. Why did you feel that these components needed to exist at layer 1, and why not have people build them as additional layers on top of the blockchain, such as has been the case with so many other systems?
Yeah, well, there's a couple of things that I think are critical, and sort of adds on to one, just the solving of the fundamental problem of being able to transact at scale. And so then, really thinking about once you've solved kind of these fundamental problems around the consensus protocol and creating a blockchain in a way that can scale. What do people want to do? And sort of, when we looked around at what people are actually using blockchains for, asset issuance is a big one for sure. Whether it's new kinds of tokens, they may be currencies, they may be security tokens. We're seeing all kinds of interesting, uses for digital asset issuance. The second is being able to trade those, but do it in a safe and secure way. But I think if you take a step back, about 15% of all crypto has been lost or stolen, and there's a lot of high profile situations where the use of Turing complete smart contracts has led to undesired consequences. And I think that's sort of one piece. The other is the need to sort of craft things within smart contracts requires a lot of duplication of what should be very simple things that people want to do every day. As a result, that's what we really looked at. What are the fundamental primitives that you need to have inside a blockchain that enable the use cases that people are doing, but do it in a way that's very simple, that avoids kind of some of the pitfalls and the possibility of bugs or other problems from cropping up. And that's sort of what led to ultimately the framework that we've created. It's really look at the fundamental elements, whether it's asset issuance, economic exchange, or being able to apply conditions under which those assets should change hands, and do that in a way that's both quite simple, but also relies on the security of the protocol rather than somebody's ability to create programs that are secure in and of themselves.
By building these functionalities directly into the layer one, do you foresee a situation where people may have use cases that fall outside of the scope of what you've built, and therefore it could be perhaps limiting to those applications?
Well, I think there's a couple of things. One, we do think there's a place for general purpose smart contracts, and I'm sure Silvio would be happy to elaborate on that a little bit more in a minute. But I think beyond that, having platforms that are fit for purpose, I think is very important. And we believe that there's going to be it's a multi-chain world. There's going to be different people focusing on different problems. Having the right fundamental sort of financial and asset primitives and blockchain primitives in place in a way that enables people to build applications, create financial products, and really expand the scope of what they're doing is critical. And so I think we're definitely not trying to boil the ocean, and we're not suggesting that the underlying primitives we've created are fit for every single purpose out there. But for what people are doing on blockchains today, we think we cover 80-90% of the territory in a way that's safe, secure, and very scalable. And I think you can start to see that happening if you think about people who are transacting across borders, people who have complex business relationships and supply chains. We're seeing a lot of interesting use cases starting to emerge. I think even beyond that, though, just as people want to tokenize more assets, I think it's a little bit misunderstood in the market. Even just finality alone, as an example, knowing who owns what is incredibly important. If you have $1 billion asset, you really need to know who owns it. And if it's owned by hundreds or thousands of people, they need to understand that as well. So I think all these things go hand in hand. We think sort of the fundamental consensus protocol and underlying technologies are incredibly important. But then also being able to do things in a straightforward way is really necessary. And I think it goes back to, one of the most fundamental things we look at is, today there's about, I don't know, you probably know the number better, but about 5 billion people, I think, on the internet. There's around 20 million developers in the world. If we're being generous, about 100,000 of those developers build blockchain applications full time, and the other 19.9 million don't. And one of the things that we think is a gigantic problem in the space is that the developer experiences today are very complicated. It requires that people learn new programming languages. It requires they learn a whole suite of technologies in order to become experts. And we think that ultimately people need to understand that a platform like Algorand is suitable for what they need and possesses the right underlying technical properties. We also need to make it really simple for them to use the tools they already know in order to start to take advantage of decentralized elements in their applications where it's appropriate. And so I think that's where, from our standpoint, some of these layer one primitives really eliminate a lot of the complexity that people are faced with when they start to get into the space, not only making a better long-term way to kind of issue assets, but also just makes it possible for people to do things in a really simple, straightforward way. And we've seen the power of simple developer experiences over and over, whether it's companies like Twilio or Stripe or others that take something that was previously very complicated and required a whole bunch of systems and really boiling it down to something very simple.
So talk a little bit about the smart contract language that you've developed, Teal, I believe it's called, and how it differs from other general purpose smart contract languages that people would be used to.
So first of all, this is a language which is very simple. It's somehow 30 instructions. Compare integers, multiply, verify a digital signature, hash, something like this. Okay, and that was not done for doing general smart contract, but we tried to put together 30 instructions that can let you do a lot of things. And as Steven said, they say, hey, most of the time people want to do, for instance, atomic swaps. That's a good idea. They want to issue and tokenize assets. That's another good idea. And they want to somehow say post and sale. So in other words, I have an asset. I want to leave for a picnic on Sunday. I posted on the chain for sale my asset, and I name a price. And I say, whoever wants to snatch this asset for this price becomes his. I go for my picnic, I come back, and I may found, I have the money I wanted, and somebody now has the asset without any interaction, right? So these are essentially fundamental primitives, or if you want to say, I give you a loan and you give me interest rate every month, and if you don't pay, then the collateral of the loan becomes automatically mine. So there is a bunch of things that the financial world they want to need, and we feel that if we give them a suite, a portfolio of ready-made templates, of course you can adjust the price, you can adjust all the various parameters, but essentially in a single line of code, you call the primitives functionality you want. I think it's going to be easier to get your job done. And if you don't find the primitive already realized in this portfolio, at least you can compose by putting together 2 or 3 of the primitives you found there. And I think that is I think as a first approach to smart contract, I think that is it goes a long way. So that is not, Teal is not intended to be a language that is for general purpose smart contract, but it does the job for 80-90% of the need for smart contracts out there. For all the examples I discussed are easily done in Teal. And so that is the job of Teal. And you must make sure that these contracts are actually executed and verified as much in the few seconds it takes to generate a block. And it cannot slow down the production of a block. So even if in a block there are 1,000, say, of these layer 1 smart contracts, the block is produced in the same amount of time, it's still in 5 seconds. I think this is pretty good. Along the side, we actually having our own architecture that as soon as we are ready to talk about, I'll be happy to be your host another time, Sebastian. It's about the general smart contract, because I think that has been a very great idea, but again, the solutions are not as satisfying as possible, because these smart contracts are very slow right now. They are very expensive, and somehow they're actually prone to error. This error comes from many sources, and not only because programming is hard, but also because when you issue an asset via smart contract, your operational definition of an asset and mine may be a very tiny difference that they become somehow arise when we actually try to treat different assets, an asset made by you with a software developed by me for handling my own assets. And that is a problem. So having this layer 1 solution for 90% of the problems, I think is a good idea, because everything is treated the same uniform manner and direct manner, and at the same level that handles the consensus protocol, which is the safest level of all of them.
So, Stephen, you were talking earlier about developer experience, and I agree that for a lot of developers who are coming into the space, there's a lot to learn when approaching blockchain platforms for the first time. I mean, so learning the language is one of those things, but I think that for the most part, it's learning about this new paradigm and how to operate within this new paradigm that is so different from what people are used to, building with more traditional platforms. One of the things that's great about general purpose smart contract languages, though, is that it has, like, all of this innovation has come out of it, right? Like, the entire DeFi space came out essentially of, one could argue, Ethereum and Solidity and what people were able to do and build in Solidity. And so I wonder if having a smart contract language that's so restrained, as a developer, if you want to go and build like the next new thing, if your scope is somewhat limited, do you think that it will cause a situation where people are not able to really innovate, but just sort of like rebuild what has already been built and mirror existing platforms or rebuild existing models on Algorand?
Well, we did a lot of analysis on this. I mean, about 85-90% of what people have used smart contracts for today could be done inside Algorand without any problem. I think there's sort of this argument about Turing complete smart contracts versus non-Turing complete smart contracts. Obviously, we fall in the non-Turing complete side. That doesn't mean that there isn't a lot of functionality and ability to cover many different use cases in there. I'd also suggest there's a big difference here between, kind of choosing a language and something else, which is when people make mistakes in sort of the blockchain and crypto world, they're typically losing people's money, including their own often. And we think that like protecting that is like job number one and, very important. And so I think that's a consideration that everybody needs, to really think carefully about. And I think there's one other point that's important to consider is that we think that the underlying language, doesn't really need, or sort of the underlying nature of the smart contract matters less than the quality of the developer tools that are around it. So as an example, we just released a Python library that allows people to use Visual Studio. They can write their scripts in Python. It makes it very easy to compile them into Teal smart contracts. We think that the space needs more of that, where people can just use the tools and languages they already know and have use that as the sort of way to interact with the underlying blockchain platforms versus having to learn something entirely new. And I think the number of developers that are willing to go learn something entirely new is not that large, and we need to really be focused on doing things that encourage new people into the market. I think that's what we're very focused on, which is less on sort of these very specific technical details and more, if you think about asset issuance, taking advantage of decentralization, thinking about like what conditions you need in order for money to change hands, atomic transfers. It's really enabling people to do all these things in a very simple way. And I think that's going to be critical, because what we really need are sort of more developers, more applications, more people taking advantage of the technology to really draw in a mainstream audience.
Sebastian, may I add something to this?
Sure.
So first of all, again, I want to make sure that layer one smart contracts are what the word says. Smart contracts in Algorand that can be done at layer one. Is this a good thing? Yes. Is this the only thing? No. This is just a stepping stone that we are going to have towards our general smart contract. But it's important to have a large suite of things that you can do safely and directly and very fast. And by the way, I want to say very cheaply, and certainly you can combine this suite of programs to write your own more simply. But if you are a developer, you know what your first concern is going to be is that the cost of gas to power a smart contract is so high that this essentially affects your bottom line. Why? Because your customer has a finite budget anyway. If I know that I write a program, it is going to be used maybe by 1 million of people. However, this 1 million of people have going to spend so much in gas. How much of their money can I transfer into my pockets to reward for my good efforts? Very small. So in a situation in which you have a layer one smart contract, it takes a milli-algo in payment. I mean, if you find something useful for humanity to do, you will find a way to be actually remunerated for your efforts. I think the cost is an important thing too, because otherwise, in the equation, this efficiency and the cost efficiency of these layer one smart contracts should not be lost.
Yeah, I agree that the cost efficiency is super important. So when it comes to the types of things that people are building on Algorand, the network went live last year. What are the use cases that you're seeing emerge on Algorand? And more specifically, like, does the company have sort of clear go-to-market strategy and for like types of applications that it's looking to encourage people to build on the platform?
Well, I think definitely if you look at sort of the suitability of the functionality we've rolled out, I think there's a lot of broad use cases that are out there. But I think what we've seen is, a lot of different people who are looking to be able to issue tokens, whether currencies or security tokens, in a way that's scalable and secure and can kind of serve their purposes over the long run, especially as they start to launch larger businesses to that effect. We've had several announcements over there of different stable coins. We've also announced partnerships with platforms like Securitize, which are it's a layer 2 platform supporting security tokens and enabling people to issue products in compliant ways. I think the second is once you have assets, atomic transfers becomes very important. So we've seen people building decentralized exchanges and other elements that sort of facilitate transfer of that. But I think more broadly, we think there's a lot of opportunity in DeFi applications. I think if you look at 2019, we started to see some of that build up. We think 2020 there's going to be a lot more focus on different ways to earn yield in crypto and ways to earn yield on platforms. And we think the underlying primitives that we've built enable people to really do that in a straightforward way. Infrastructural components like Securitize that build on top of Algorand. Others are going to be more financial products that launch that we think are really exciting, and all those require assets to be on chain. So I think that's sort of one sort of fundamental area. The other, we're seeing I think really interesting business use cases that just lend themselves towards being in a decentralized economy. Things like supply chain and really understanding like whether certain conditions are met. An example is transporting perishable goods, making sure that they reach they're sort of at a consistent temperature, that no triggers have been run before they get delivered, and payment happening automatically as long as those conditions are met. So we're starting to see more a variety of decentralized applications starting to roll out kind of along those that are I'd say more business use cases. I think generally though it's a combination of one, getting the right infrastructure in place, getting the right assets on chain, really being an enabler for new and innovative DeFi applications. The second is continuing to broaden our developer tools and encourage more business use cases that are sort of fundamentally interesting for decentralization. And then I think beyond that, what we've started to see, I'd say more from an overall perspective is while there's a ton of innovation in the DeFi space, fundamentally there's not that many users and not that much money floating around in there. And there's a traditional financial world that materially has all the world's money, but it's much slower to adopt. And we think a platform like Algorand, and more specifically a company like Algorand that just has experience working with people in different settings, is important to kind of bring those two together. Because I think definitely the traditional financial world has interest in the innovation that's happening, but I think it hasn't really been presented to them necessarily in a way that they can take advantage of.
I see. Now, can you tell me about the Algren Foundation and the role that it will play moving forward with regards to the company?
Sure. So first, I guess I'll just clarify, Algorand Inc. is a U.S. company. We're based in Boston. We are creators of technology. Obviously, we're one of the core developers of the Algren protocol, but we also build other software here. And, our sort of go-to-market model is similar to, other open source projects like Red Hat or MongoDB, where, we'll ultimately continue working on the tech, but also we'll provide value-added services to people who are looking to build in the space. The Algren Foundation is responsible for overseeing governance of the public network, and separately responsible for the issuance of the algo as a token. And so, their responsibilities are really kind of fundamentally around that, along with community awareness and continuing to develop the ecosystem.
And so where's the foundation based?
A foundation is based in Singapore.
Oh, okay. Oh, interesting. And so then the foundation manages the issuance of the public network, you said. So I presume then that
Governance of the public network.
Oh, sorry, governance of the public network. That I presume then that Algorand can also be used in a permission setting. So are you pursuing also that as a business, like implementing permission networks for clients?
Well, for sure, we think that there's going to be need for different ways of interacting with the technology. I think we feel it's very important to solve the public permissionless, or have a public permissionless network as sort of the fundamental basis for everything. And even if people are creating their own chains, we feel they should be derived from the public network. Silvio may want to elaborate on that a little bit more, but
yeah. So let's put this away. Is there a need for using a permissioned version of Algorand? Absolutely, because very often certain industry in particular are regulated. Think about healthcare or think about financial network, and they need to have. They cannot have their transaction to be visible to an open public network. So therefore, you can use Algorand because and its consensus protocol. In fact, the same algorithm, absolutely, but in a permissioned, shielded away way to get a permission version of Algorand. Why to build a permission network on Algorand? Well, there is a variety of reasons. Reason number one is that, frankly, you may want to scale it later, and you can start, say, with 12 validators, and then increase them to 100, and then increase it to 1,000, or hundreds of thousands, or millions or billions if you want. Why do you want to do that? Well, because assume that you have a financial network, perhaps of 5 large banks that decided to cooperate during a permission within a permissioned blockchain. But then later, what if they want to enlarge their club to serve also medium-sized banks, then small banks, then credit unions? Well, now we are talking about thousands and thousands, right? And then at that point, if everybody wants to participate to consensus, how do you accommodate them? A consensus mechanism that is good for 10 may not work for 100 or for 1,000 or for 10,000, etc., etc. And it's going to be very hard to change yours in the middle of a race. So you are going to risk the problem to have a legacy problem in 6 months if you want to do it. Instead, because scaling down is easy, scaling up is hard. But if you start with a blockchain that scales to the billions, you can certainly start with that, and you know that scalability upwards and decentralized upwards, if you want, is never going to be a problem. The second reason you want to have it to say, hey, I like this layer one immediate layer one contract. So if you have Algorand, permission version of Algorand, not only you have Peel, not only you have atomic swaps, etc., but you are going to have any other innovation that is going to be in the Algorand network right away. Who doesn't want to have automatically? I mean, who doesn't want to have layer one smart contract for those smart contracts that you can do in layer one? I mean, the answer is a clear yes. But finally, I think that a main reason to use Algorand is that we have this architecture for having a co-chain, which is a permission version of Algorand, when not only is completely autonomous, they choose their own validators and they run their own consensus mechanism. They are totally autonomous. But by being a co-chain of Algorand, what you have is the ability to interact with another co-chain. And that, I think, it is an incredible advantage. Because very often people fall into the trap to know with whom they want to interact in the future. So you say, oh, I'm a bank, I'm a financial institution. I know with whom I want to interact, with other banks and other financial institutions. That's why we are building this blockchain with our, say, 10 financial institutions. But would you be surprised if another 10 big pharmaceuticals or hospitals, they form their own healthcare blockchain? Not at all. Well, if healthcare is 20% of the economy, is it credible that a blockchain made by financial institution don't want to interact with 20% of economy? Of course, they will eventually interact. But guess what? At that point, unless you get into this co-chain infrastructure, by having your own permission blockchain, you are imprisoned by your own castle. You can, with transparency, speed, and everything else, interact inside your own original constituency, but you are blocked, prevented from actually interacting. And when people say, "Oh, but we have some interoperability program," yeah, claiming is easy. Claiming interoperability is easy. The question is really, how do you actually implement it? And by the Algorand co-chain, that is a great way to enjoy your cake and eat it too. And because you can actually not only act with transparency and efficiency and trust inside, but also with the outside world. And strange enough, actually, you can actually take advantage also of the permissionless blockchain to facilitate this interaction.
One of the roles of the core chains would be to facilitate communications between sort of permission chains by providing an interoperability layer. Is that correct?
Yeah. Let me give you an example, right? Assume now you are a member of the blue chain. You actually are, right? I am a member of the red chain. And Stephen is the Algorand main permissionless chain. So you and I, Sebastian, the blue chain and the red chain are permission, but they are co-chains of Algorand, right? As I said, I eventually say, "Hey, gee, Sebastian, you have a very interesting asset you have here. Call it the circle. I have a very interesting asset to you. Call it the triangle. How do we swap it?" Okay. If you and I were in the same co-chain, by an atomic swap of Algorand, we can swap in a few seconds, done. But we are in different co-chain. And so I must be careful, because if you don't trust me, in particular, if I create a big opaque pipe by which you and I can exchange the triangle and the circle, how do you know that I'm not selling the triangle 2 or 3 times over to other co-chain in another separate and opaque manner? You'll never know. So instead, conceptually what you want to do is that it's very easy for me to assign the triangle to my same public key in the Algorand chain. Why?
Right.
Because the Algorand main chain is permissionless. So my public key is automatically a key of the main chain Algorand.
So it's similar to the way that the Cosmos works, for instance. So I mean, the Cosmos hub interacts with all the zones, and then these assets that live on the zones can use the atomic swapping mechanism within the Cosmos hub to interoperate.
Well, you can say that way. I mean, the devil's in the details. What an atomic swap is the different things to different chains. But at the high level, that is the way in which I think, in general, to have there is a role for a permissionless public blockchain, because the permissionless allows you an immediate transfer to the main chain and backwards. And once you are in the public chain, you allow the item, not who owns the item, right, to know. And when I transfer the item to the main chain, first I transfer to a temporary public key, so you don't even know which public key owns in the red chain the triangle, and I don't know which public key owns in the blue chain the circle. You transfer to temporary key in your own chain first. These temporary keys own in the main Algorand thing, they swap there, they swap it back. So I think that the public aspect, the permissionless aspect, is very easy to bring it to the main chain, and the public aspect is to say, "Oh, everybody knows now that I don't know to whom it belongs, but the triangle now is in the red chain and the circle now is in the blue chain." So that I am prevented to give it to other people. So I think finding the right synergy between permission and permissionless blockchain is very crucial. But there again, which chain you want to use? You want to use the permissionless chain as a backbone that has the best smart contracts, the best means to interact with each other, atomic swaps at layer 1, and not as a smart contracts, and so on and so forth.
So what's next for Algorand, and where can people find you?
One of the things, as you can, hear from Silvio, is not only is sort of the core protocol kind of something that we thought was important, but continual innovation is something that we're very focused on. That led to Algren version 2, which was released only a few months after mainnet launch. There's continued innovation going on around co-chains and other areas. So I'd suggest everyone kind of stay tuned. Also kind of, ensuring that, there's a variety of layer 2 applications that enable developers continuing to kind of build on the portfolio of tools that we've already released. I think those are the things we're hard at work at over here. And in terms of finding us, would encourage anybody, please come to our website, which is algorand.com. There's links to our social media presence there, and a lot of information on the project. And for anybody who's looking to build applications on top of Algorand, developer.algorand.org has a variety of developer materials and information on how to get involved technically. But it's been really exciting. First 6-7 months since launch, and we've been really excited about the response we've seen out in the market.
Great. Well, Steven, Silvio, thanks again for coming on the podcast.
Thank you, Sebastian. It's been a pleasure to be with you and your audience.
Thank you, Sebastian, for having us. It was great talking to you.
Thank you for joining us on this week's episode. We release new episodes every week. You can find and subscribe to the show on iTunes, Spotify, YouTube, SoundCloud, or wherever you listen to podcasts. And if you have a Google Home or Alexa device, you can tell it to listen to the latest episode of the Epicenter podcast. Go to epicenter.tv/subscribe for a full list of places where you can watch and listen. And while you're there, be sure to sign up for the newsletter so you get new episodes in your inbox as they're released. If you want to interact with us, the guests, or other podcast listeners, you can follow us on Twitter. And please leave us a review on iTunes. It helps people find the show, and we're always happy to read them. So thanks so much, and we look forward to being back next week.